Hi, welcome to Sam Tech Pro. Today in this tutorial we're gonna be taking a look of this welding inverter. This is not just a welding inverter, it's basically a dirt cheap welding inverter. And what it cost me about $150 or something, including the shipment to my country, which is 7 oceans far from the seller. And that clearly means the cost of this inverter is around about $75 or $85. And this is not just the inverter. It's a dirt cheap inverter. And I will take a look that does it actually work or not. So we will do some weld. But before that, I would like to introduce some of the parts that it comes with. This is the mask, welding mask. There is a good glass that is only visible when you weld something to the high intensity light, we can say. Now this is the power cord cable. Of course, this is really very thick, but I don't really think that it is suitable for a welding inverter that is actually capable of supplying 200 amperes. This is something that I think welders know better. What is this? But they just use it for as a hammer to remove. This is the electrode cable. This is the positive electrode. So the red color mean that this is a DC welding inverter, and this is the ground plug. Of course, made of good quality. They just have attached the wire to the end of the clip with the copper parts, just to avoid unnecessary heating in the clip. This is really a dirt cheap inverter, and what I'm gonna do right now, I'm getting naughty this time, and what I'm gonna do, I'm gonna tear it down. No, I'm not gonna tear it down, because this is really very cool. It looks beautiful, but at least I think there will be no problem if I open the top case of this inverter. But before that, let's see what's warning is written. Nothing is written. I see the power switch, wow, and the fan, of course, for cooling purpose. Now here is 60% is the duty cycle at 200 amperes, while 100%, what? 60% duty cycle on 200 ampere, and on 155 100% cycle. How can it be like that? 60% means you can weld about 10 to 12 minutes on 200 amperes before the thermal runaway of the components inside it, and it will absolutely burn because there will be no protection component. So here we are inside this inverter. Oops, looks like I was wrong. There are protection features inside it. Anyways, let's start from here. This is the copper terminal for the ground connection, and this aluminum connection for the electrode that is connected to this heatsink. That heatsink, I believe, contains the IGBTs or the MOSFETs. Now this is the transformer, the toroid ring. Let me provide you a reference scale. That is my hand. Now these are two capacitors. These capacitors are dangerous, contains little voltage, and they keep the inverter turned on even when you unplug the device. You have to wait until the capacitor discharged. The power switch does nothing at all. This is just a connection between your power cable and the bridge rectifier. The bridge rectifier is here. It is mounted on the same heatsink on which MOSFET is attached. I don't think it could get any kind of special heat which could burn something. So nice shielding and the wires are really very thick. This is huge transformer. I see the thermistor, which is connected to this kit, and this looks like this kit looks like the pure sine wave inverter board or something. I don't know what this kit is doing here, but I'm not gonna deep checking that what components are on it and what it actually doing. Now there is a heatsink on, there is a thermistor that is connected here, so that might be a sensitive point where they connected that thermistor, but as this is dirt cheap, anything could fail. Now the back side of the board is really cool. I like the design of the person who did this. This is really very simple. It would definitely help me troubleshooting whenever the problem will occur. I hope no problem occurs. I have already tested it about 2 to 3 times, and I did short works with it. The purpose that I bought this welding inverter, I am an electronics engineer. I don't have anything to do with the welding, but the purpose is that I love to explore things, and I love to take a look deep into the circuits that people are building. And the design, especially the design comes from the China. There is a lot of things to learn about the design. Now here we see the gap. This is the tiny gap, but this keeps it insulated. So that's all. I think it would do the job for a little bit task of mine. If the welding work is required, I will do myself. So here I got the welding inverter on, and I'm gonna do the welds. Now I don't know much about welding, but I will learn everything soon. So this is the second stick I'm gonna using, and this stick has a number 12. Oh my gosh, the chassis was connected to the ground, and this is the wrong thing that I did. Let's see if it works. Why the hell it is sticking? This is currently on low amperes, by the way, but that's still enough for welding. I think this is material
the lowest speed
is isolated. This is the high speed. With the high speed, I think this speed is not good for the welding, because I see the welding on 2 to 3 points in this straight line. So I'm gonna try once again with the slowest possible speed. Now I am running the electrode real slow, and I'm not good at welding, but I think I got some decent results for the welding. I have recently burned these points because I didn't have any idea. Now what I'm gonna do, I'm gonna releasing all of the amperes, which are total 200 amperes, and then we'll try to see the arc. And this is sticking. This is the spark. Oh my gosh. Oh my gosh. This is a real huge spark.
A large
and
amount of current, and I just
the metal is gone.
cool.
Now this means that 200 amperes are not absolutely the right option for such thin metals. This is not really very thin, by the way. Alright, anyways, I hope you enjoyed this video, and I'll keep making the projects related to welding, which includes welding, we can say. So please keep supporting me by subscribing, liking this video, and share this video. Thank you.